Hi, this is Lee, and this is another video in my tutorial series on ACT and SAT problems. Today we're going to be dealing with a fairly common problem you see on the ACT and SAT, and that is shapes inscribed inside of each other. The most popular one you see is usually a circle inscribed inside of a square, and that'll look like this. When they say inscribed, they mean that the edges perfectly touch the edges of the other shape, so that the circle perfectly fits inside the square without going over the boundary, and it's not so small that there's some space left between the sides of the square and the edges of the circle. So in general, what they'll do is they'll give you one of the dimensions of the square and then ask you for a dimension of the circle. And so you need to know a way to translate between those two shapes. So first, let's start with the fundamentals of each shape. Each of them have a fundamental dimension that determines all its other characteristics. So let's just go ahead and we're going to write square and circle. Okay. So for a square, the fundamental dimension is the length of the side. So let's just call that S. Okay, now if you want to know what the perimeter of the square is, you just add up all the sides of the square, and that would be 1s, 2s, 3s, and 4s. So we'll say the perimeter is equal to 4s. Then if you want to find the area, you say, oh, okay, well, you just multiply one side times the other side. Length times width, but in the case of a square, the length is equal to the width. So it's just s times s, which is s squared. So the area equal to s squared. Okay, now we're on to the circle. We need to know what the fundamental dimension of a circle is, and as everyone knows, it's the radius. The radius determines the circumference and the area. So this is the radius here. The radius is just drawn from the center of the circle to any of the edges. And so if we want to know the perimeter of a circle, is called actually the circumference. So the circumference of a circle is given by the equation 2 pi r. And the area is given by pi r squared. Okay, now that we have those, we need to know a way to get between these two shapes. So we need to know how the side is related to the radius. So if we look closely here, we see, oh, well, if this is the radius, then that's the radius, and this is also the radius. So we can see here, oh, all right, we can come up with a quick relation. Okay, well, the side is just equal to 2 times the radius. And this is what we're looking for. This is how you get between the square and the circle. So let's try an example of this. A common problem you see involving inscribed shapes is they'll give you some shaded area. So let's say that we shade in this area right here. So the key to working with any shaded areas is to know that you're going to start with the shape that encompasses that whole area and then subtract the shape that's inside of it, or the white area. So in this case, we can see, all right, so if we took the area of the square and subtracted the area of the circle, we would get the remaining shaded area. And again, in the context of this problem, they'll usually say something like, let's say they give us the perimeter is 10, the perimeter is 10 pi. Okay. Sorry, the circumference. The circumference is 10 pi. Okay, so they say, all right, the circumference is 10 pi. What is this area? The shaded area. Okay, so then you need to say, all right, well, I know that I'm going to have to take the area of the square and subtract out the area of the circle. So we could just write an equation for that. So we'll say the area of the shaded region, just say A shade, is equal to the area of the square, which is s squared, minus the area of the circle, which is pi r squared. And now we just need to know in terms of the radius. So if we see here, oh, the side is equal to 2 times the radius, well then if we write this just in terms of r, we can say, oh, okay, well this just is 4r squared minus pi r squared. And you could reduce it even further and say, oh, okay, well actually this is r squared times 4 minus pi, but I don't think that's important for this problem. Now the only thing is we need to know what the radius is. Well, if the circumference is equal to 2 pi r, then we can see, even without solving it, that the radius is going to be 5. But if you wanted to be explicit, you could say, okay, well, I'll just divide each side by 2 pi, and that'll lead me to r equals 5. And you plug in r equals 5 to this, and that would give you the area of the shaded region. I hope this has been helpful. Keep in track of my videos for more tutorials. Thank you.